Okay, we want to talk about the sprayers. This can be used to deliver pesticides. First, we have a knapsack sprayer, which is handheld. It can be put on the back of the operator, and it has got a handle which is linked to a pump, which can be used to build pressure, which is used to drive the liquid out of the knapsack sprayer. And this liquid will pass through a nozzle. Here again, another knapsack sprayer. They come in various forms. By the way, there are now other sprayers which use batteries. You just switch it on so that the pump can drive the liquid out of the knapsack sprayer. Here is a tractor boom sprayer, which has got a big tank, and the liquid is delivered through nozzles. This is the boom width, which can cover quite a wide area. Here we've got a sprayer which is attached to a drone. A drone can be used for spraying purposes. Here we've got a helicopter attached with a sprayer, spraying a maize field. So we have got this helicopter with the attached boom spraying the field. Light aircraft can also be used for spraying. Again, a drone being used to apply pesticides. You can see the drone can be very small, and it can deliver the spray as very small droplets. So we are going to move on to how we actually use these sprayers. What is important is to calibrate them before you use them to spray the pesticides. So now you have a general idea about how the sprayers could be used. Either handheld sprayer, you can use tractor-mounted sprayer, or you can use an area mounted sprayer. So from this short introduction about sprayers, we're going to talk about sprayer calibration. So let us talk about the application of pesticides. Before you can apply your pesticide, there's need to calibrate the sprayer. We may use the herbicide as an example. For example, you may have the herbicide rates or dosage rates. You may have the herbicide rates or dosages in mils or liters per hectare. For example, atrazine is a herbicide used to control weeds in maize. The recommendation is that you have to put 3.5 liters per hectare for sandy soils. Now, this is the rate we want to put per hectare. So how do we make sure that our sprayer can deliver a rate which is equivalent to 3.5 liters per hectare when spraying? The herbicide has to be mixed with water and sprayed via nozzles. Later on, I will talk about nozzles. Now, the objective is to determine the amount of water required to spray 1 hectare or a spray rate. So we want to find out using a certain nozzle how much our knapsack sprayer can deliver to cover 1 hectare. That amount of liquid is what we call the spray rate. So you can have this knapsack sprayer. This is the lance fitted with a nozzle. This is the handle, which is used to pump so that you can drive the liquid out of the sprayer. So our task is to find out, if we are using this sprayer, how much water are we going to spray to cover 1 hectare. There are types of nozzles which can be fitted on the knapsack sprayer. We can have this, which is known as the hollow cone. But the hollow cone, please note, this is for insecticides, and we can also use it for fungicides. This one, the flat fan nozzle, is for herbicides. I shall be talking about these nozzles. Now, this nozzle has got a tapered edged flat. We describe it as a tapered edged flat fan spray nozzle because of the shape or the pattern of spray which is coming out of this nozzle. Now, there's a need to correct overlapping because sometimes you can end up over applying the herbicide. If you have nozzles which are on a tractor boom, So this is the flat fan nozzle. You can see this shape of the spray. Here I've got a diagram of this flat fan nozzle spray pattern. You can see at the edges, it is, we can describe this as tapered end. It's not smooth, or it's not a straight line, sorry. So you can see where I've put some lines to demarcate straight lines. So when you have a series of these nozzles, you make sure that you control these overlapping ends. And when you are taking the width of the spray, we measure the distance between these lines as the spray width. Now, if you had a series of these nozzles, you make sure that they are at a distance where the tapered ends will overlap in such a way that you don't over-apply the pesticide. Now, I want to talk about the even spray flat fan. This one gives a uniform spray across the entire width of the fan. It is recommended for bend spraying. So even spray flat fan is recommended for bend spraying. I will show you what it looks like. The difference with the previous nozzle is that here at the edge, we do not have a tapered end. It's almost a straight line. Let me, well, here we've got a tapered end. So this is the flat fan nozzle. This type of nozzle, it's the flat fan nozzle. The number 2 nozzle is even spray flat fan. Even spray flat fan. Even because the edges are almost straight lines. You can see after spraying, the edges are almost a straight line. You don't have a tapered end like the previous nozzle. The third nozzle is known as the flat jet nozzles. You know, if you have a liquid, it will hit at this background at right angles. Then the jet of water is going to split into droplets. Well, I just wanted to show you 3 types of nozzles which are used for herbicide application. If I go back a bit, the hollow cone nozzle is for insecticides and fungicides. But with the herbicide, we've got 3 types. We've got the flat fan nozzle, which create tapered ends. So flat fan nozzle, sometimes it's confusing with the next one. Even spray flat fan. So even spray flat fan, which has got that broad ends. It doesn't have a tapered end, so it's an even spray flat fan nozzle. And the third for herbicides is the flood jet nozzles. So we talk about sprayer calibration. Here I've got a diagram with somebody carrying a knapsack sprayer. This is the lance, and this is the position of the nozzle. After spraying, we've got this length, which we call swat width, if you want. And this is the height of the nozzle. Normally, a person can spray the herbicide comfortably, holding the lance, which is about 1 meter from the ground. And the person is supposed to maintain this height. Sometimes we tie a string here and a weight at the end, so that it can guide somebody who is spraying to maintain the height of the nozzle above ground. Now, when you are calibrating, you need a stopwatch or even a watch measuring tape and measuring a cylinder. I think nowadays you can also use your phone for timing. It can allow you a stopwatch. There's a function for stopwatch if you want, or you can buy one, stopwatch. So stopwatch to keep time, measuring cylinder for measuring the volume, and the measuring tape for measuring the distance sprayed. Now, let us look at the steps or the procedures which we need when we are calibrating a sprayer, which could be first a knapsack sprayer. Number 1, we need to select our nozzles. I've already shown you various nozzles. We have a hollow cone, an even flat fan nozzle, or a flat fan nozzle, a flat jet nozzle, whichever you want to choose, depending on the purpose of your pesticide application. The second stage, when you have chosen your nozzle, is to fill the tank with water of the knapsack and operate the pump to maintain pressure of around 1.4 bars. Now, you may find that on some knapsack sprayers, you don't have a gauge, but you can set the sprayer so that when you are pumping, it reaches around 1.4 bars. Or you can simply fit a pressure gauge to guide you. That will be more accurate. Now, when spraying, we want to maintain the height of the nozzle tip above the ground. It should be constant. And we can use this by tying a string on the lance to a weight so that at least we can maintain the height. This will be your choice, the height. It could be up to 1 meter. So this is the nozzle position. This is the height. And this is the spray coming from the nozzle. If you had used the flat fan nozzle, which are commonly supplied, these are the common nozzles fitted on the knapsack sprayer. What you may have to do is to find a dry surface and spray. The droplets will mark that dry surface. So you can mark out these straight lines immediately and measure what we call the swath or swat width. So it is the distance between these 2 points after spraying on a dry surface. Then you need to walk a distance of 60 meters while pumping the sprayer steadily and determine the time taken to cover 60 meters. So you actually put your knapsack sprayer on your back, start pumping it, and you have to spray a distance of 60 meters, as if you are actually doing it in the field. Now, what we wanted to do is we wanted to find out the time which is taken to spray a distance of 60 meters. We can do it 3 times. Then find the average. So after putting the sprayer on our backs, we start pumping the sprayer. We walk a distance of 60 meters. We repeat it 3 times. And each time we are doing it, we are measuring the time taken to travel 60 meters. We should find the mean of that time. Usually it's in seconds. Now, we should also want to determine the amount of liquid which is sprayed on the 60-meter length delivered by the knapsack. I have chosen 60 meters. It could be 30 meters, depending on what you want. It could be 100 meters even. So how do we determine the amount of liquid sprayed? Now, if we know the time taken to travel, the 60 meters, we can pump this knapsack sprayer for that duration and measure the output. We can do it 3 times. Or what you can do is that when we have filled the knapsack sprayer, after spraying 60 meters, we find out how much we have actually sprayed. Normally, the knapsack sprayer has got is marked in liters. The capacity of the knapsack tank is actually graduated. You can know how much you have actually lost during spraying. But otherwise, you may have to use a measuring cylinder, pump the liquid out for the duration in which you are supposed to cover 60 meters. Do it 3 times and find the mean. That should be the mean output. So the information which is required, or the data which is required, we have got 4 things which we should be recording. Number 1, we need to know the swat width, or width sprayed in meters. We need to know the distance traveled during spraying. We have said 60 meters. We need to know the time taken to walk 60 meters in seconds. We also need to know the amount of liquid which has been sprayed when walking 60 meters in liters. So those are the 4 things. Okay, just for emphasis sake, SWAT should be in meters. Time taken to travel 60 meters should be in seconds. Mean volume delivered should be in liters. The area sprayed is the swath in meters times the distance traveled, which is 60 meters. And this should be in square meters. Then we have to do these calculations. What we need is to determine the spray rate, or the amount of water required to spray 10,000 square meters, which is simply 1 hectare. We want to find out how much is delivered by the knapsack sprayer to cover 1 hectare. But from our estimation covering 60 meters times swath in swath width, we have to know the amount of liquid which has been sprayed to cover that area. Once we know it, then we have to say how much should go on 1 hectare or 10,000 square meters. Now, using that formula in red, we can say in brackets mean volume liters, which were sprayed to cover 60 times the swath in meters, multiplied by 10,000 square meters, divided by 60 times swath. That simple proportion should give us the spray rate. If we're using this example, let's suppose the swath was 1 meter. And the distance covered was, let's say, 30 meters. In our previous example, I know we have used the 60 meters. Let's suppose we have 30 meters. Time taken to walk 30 meters, let's say it's 30 seconds. If it was 60 meters, probably it would be 60 seconds. Amount of liquid sprayed when walking 30 meters, probably we have got 0.55 liters. Then, in order to determine the amount of liquid applied per hectare, then we should have this 0.55 times 10,000 divided by 10 by 30 meters times 1 meter. This now gives us 183. So if we take all of the data, we should use this formula to estimate the spray rate. So what it means is that using a knapsack sprayer, if you want to cover 1 hectare, you need 183 liters of water to do it. The next step is to find the amount of herbicide which is required. Because we now know that 183 liters per hectare is our spray rate. For example, we can use a MCPA, which is recommended to be used at 3 liters per hectare. If our tank capacity for the knapsack sprayer is 15 liters, how much of MCPA do we need to add to our tank so that we form a solution of the herbicide which is about 15 liters? Again, using simple proportion, we can say 3 liters times 15 times 1,000 divided by 183. We multiply by 1,000 so that we convert everything to mils, which we can measure. So if we are going to mix MCPA with water, we will need 246 mils to add to water so that we form a solution which is 15 liters. So this is how we can calibrate a knapsack sprayer. We can use the same principle for a tractor boom sprayer like this one. In fact, any sprayer, we can use this principle. This is a tractor boom sprayer. Now, the difference is that on a knapsack sprayer, we are dealing with one nozzle. And on a tractor boom sprayer, there are several nozzles. Here you can see a lot of people who are trying to measure the output from various nozzles, which means, or it implies that if you want to calibrate a boom sprayer, a tractor boom sprayer, you may require several people. But in fact, you can do it with a few people. Now, when you want to calibrate the tractor boom sprayer, you need to know the distance which is going to be traveled by the tractor. You also need to know the boom width. Now, the pump of that sprayer is driven by the power takeoff of the tractor. You need to fit in nozzles on the boom, which will give you the spray output range that you require. In fact, you need to fit, you have to know the pesticide which you are applying. If it is the herbicide, you need to put in the correct nozzles. You also need to select the number of revs per minute. This will give you the spraying speed. The spraying speed is normally between 5 and 6 kilometers per hour. And you get it by adjusting the revs per minute. Now you can choose a field which is 100 meters long. And this distance should be covered by the tractor carrying the sprayer filled with water. And you should actually be spraying when you are running the 100 meters. We know that the tractor is a speedometer, which can give you the distance being traveled, either per minute or per second. But we need to find the time taken by the tractor to cover 100 meters using a stopwatch. This can actually be done 3 times. The tractor spraying that field, which is 100 meters. Now, you should collect the spray output from nozzles for a period equivalent to the time required to travel 100 meters in the field. Normally, you can use 1 or 2 nozzles for this. Now, you need to determine the swat width. How you do it, you count the number of nozzles on the boom. You also have to measure the distance between 2 nozzles. Now, the swat width is the number of nozzles multiplied by the distance between nozzles. E.g., it could be, after doing this, you may find a swath which is around 6 meters, depending on the number of nozzles. For example, 30 nozzles which are spaced at 50 centimeter intervals. The swath could be calculated as 30 times 50 divided by 100 centimeters, and you get 15 meters. You also need to determine the spray rate. Now for spray rate, if you want, you could collect water from a couple of nozzles, depending with the manpower which you have. You run you spray the liquid for the equivalent time, which is supposed to cover 100 meters. Then you have to find out from the number of nozzles which are fitted on the boom how much liquid has actually been sprayed. If you have got, let's say, 30 nozzles, and you have got 30 people, you can measure each nozzle if you want, if you have got a lot of labor. But if you have got 2 or 3 people, you can just measure the output of 3 nozzles and find the average output of 1 nozzle. Then you use that one to estimate how much liquid is actually lost during spraying to cover 100 meters. So the spray rate is equivalent to 10,000 square meters multiplied by spray volume collected for the time taken to travel 100 meters, divided by Swat width times 100, which is the area. Here is an example which can help us to understand the tractor boom calibration. For example, let's suppose we have got the number of nozzles which are 12, and these are fitted on the 50 centimeter, and they are 50 centimeters apart. So we proceed to calculate the Swat width of the boom by finding the product of 12 and 50. So we multiply 12 times 50 divided by 100 centimeters, then we get a Swat width of 6 meters. We wanted the area to be covered, which is 10,000 square meters or 1 hectare. We know the distance traveled by the tractor is 100 meters. So the area covered by the tractor in one pass should be 100 meters times 6 meters, which is 600 square meters. Let's suppose one nozzle discharges 1.5 liters per minute. That is one nozzle. We have to find out the discharge of 12 nozzles by simply multiplying 1.5 times 12 to get 18 liters. Like what I said, you could just use one nozzle, measure it, or you can use the 3 nozzles, or you can measure all of them if you want. But suppose you just measure one nozzle, you can estimate what 12 nozzles are discharging, which is about 18 liters. So your spray rate in liters per hectare could be 10,000 square meters times 18, which is the output of the nozzles, divided by the area, which is 600 meters. And it gives you around 300 liters per hectare. But sometimes, if you get such a rate, you may have to check your nozzles again. They may need replacement if these are herbicide nozzles, so that you get something which is around 200 to 250. liters per hectare, but 300 liters per hectare is still okay. We want to find out how much MCPA should we put in the tank. Now, for a tractor, the capacity could be 200 liters per hectare, as opposed to, NEPSEC, we are saying 15 liters per hectare. And if the application rate is for MCPA is 3 liters per hectare, how much herbicide is needed to make a spray solution of 200 liters? So the calculation is as follows. The amount of MCPA could be 200 times 3 divided by 300, which is now 2 liters. So you need to measure about 2 liters of MCPA and mix with water so that you make a solution which is about 200 liters. And probably if you spray this, it should cover nearly 1 hectare, or just under 1 hectare, because you need 300 liters to cover 1 hectare. So this is the end. I will stop here. Hello?
Hello, Doc.
It looks like we've lost someone.
Yeah, maybe it's a network problem.
Yeah.
I it's not in.
Anyway, firstly, I showed you a range of sprayers. I mean, knapsack sprayer, tractor-mounted sprayer. You can use even small aircraft to spray. Then after that, we talked about the calibration of sprayers. Now, as long as you can calibrate a knapsack sprayer, you can calibrate another sprayer using the same principles. Probably it may be easier when it comes to tractor-mounted sprayers, because you can set things. You are not actually pumping the sprayer yourself. But I understand there are now some nozzle, some sprayers which operate using batteries, and you don't need to pump physically. But I don't know how long they last, these batteries. But in town, these sprayers are available. Any questions on beside the calibration?
No questions, Doc.
Yeah, the next stage was that I was going to talk about nozzles. Now we have, there are now 2 of you, and the issue on nozzles may actually take us an hour. I was of the opinion that I may end it here, so that we may continue tomorrow. What do you think?
I think it's okay, but I'm not sure about the timetable for tomorrow. Because we are supposed to do a lecture with Mem Ngazi.
When are you supposed to do it?
I'm not sure of the timetable now. I have to check with others. Then we will let you know.
Are you likely to do it in the afternoon?
Yes. It's
Okay.
afternoon.
All right. You said in the morning it's difficult for you to do it.
Yes.
Okay. Let me stop recording so that we